What is simple harmonic motion? Imagine I get a spring and I dangle something off the end of the spring. Actually, even just imagine a spring. You pull a spring, and the further you pull it out, the harder it pulls back. This is easy to move, but you pull it further out, it gets harder and harder and harder to stretch more. So for a spring, you have to write this at this point. The spring says the force, it's called the restoring force, is proportional to the distance you have displaced it. Right? Except if I'm pulling it out, the force goes back in. So it's negative. Now we know that force is actually mass times acceleration. And I can hide the mass in this constant. And so what I actually want to go is acceleration is negative some constant times displacement. That is this. Acceleration is negative something times displacement. That's what makes simple harmonic motion. If I write acceleration as the second derivative of, with respect to time, negative kx, right? K is some constant. I'm actually going to replace k with something else in a minute, but this will do to get us thinking and trying to work this out. The second derivative is equal to negative a constant times the original displacement. Can you think of a function whose second derivative is negative of itself? I get my function, I differentiate again, I get back to where I started, but with a negative sign.
Is it another trigonometry?
It is! Think about it. If I get sine and I differentiate, what do I get?
Cos.
And then if I differentiate again, what do I get?
Negative sign.
Look at that. And if I start with cos and differentiate, what do I get?
Negative sign.
Something other than Rain or Eddie. What do I have to differentiate negative sign?
Negative cos.
Correct. Correct. This is negative of what I started with. So this differential equation has the solution, whoopsie, the solution is x is some kind of sine function. Now I'm going to write it in a particular way. Or cos. Maybe I should write that. Or a cos omega time plus something. Why did I choose omega? Because it comes from physics. Do you know what an omega looks like? That's not a capital omega for ohms. This is a small omega. You can put almost anything you like here, but traditionally we put omega. This year 11s have recently done trig modelling, right? Where you've gone A sine bx plus c plus d, right? You people have done that recently?
Oh yeah, alpha.
It's an alpha. Oh yeah, it's an alpha. It doesn't really matter. You can label them whatever you like, but traditionally we use Greek letters for angles and Roman letters for the rest. So what happens if I take my sine, just going to do the sine, the same thing happens with cos. If I get the sine, then x dot, remember dx dt, is going to be what? What's my first derivative? Chain rule. Inside doesn't change. Then I'm going to multiply by that omega. And then the second derivative is going to be no, it's now, I got that wrong, it's not sine, nobody noticed?
Oh, I thought it was.
Come on people, it's cos. First derivative, second derivative goes back to sine negative omega squared. So we will actually be writing this, acceleration is minus omega squared x. If you can write it like this, you know already what the period of your trig function is. If you can write it in the form of something squared, you can already pick this in your model. Then all you have to do is solve for the horizontal shift. So this is the equation you will always see for simple harmonic motion. There are some words you need to know, but you probably already know them. Period, amplitude, you know those kinds of words. Be careful though, period in particular, we are talking in time. T is time for one complete oscillation. Cycle, call it whatever you like. How long it takes to go completely forwards and back to where it started. Think of the thing hanging on the spring, down, up, down, up. That's your cycle. That's the period. Amplitude. We already have a letter for that. It's the distance away from equilibrium. Max displacement from equilibrium. I should say that. From equilibrium. There's too many vertical short lines.
Do we ever shift these vertically?
There's no reason why you couldn't. We don't normally write it there, but if you were doing a model of a real world thing, you could. Or you could just say the origin is at the equilibrium position in your model, when you write your model there.
Yeah, yep.
Do it whichever way you prefer. Yeah, let's have a go. A particle, oh, we love our particles. A particle is oscillating. Oscillating. Is my writing big enough? Maybe I'll go a bit bigger. With simple harmonic motion, I'm not going to write that out. Everyone who's done a physics motion course at any time at this kind of level will know what SHM is. We all learn that. SHM with period 5 seconds. Determine the time taken. Determine the time taken to move from equilibrium position to half its amplitude for the first time. Equilibrium, I have to write it again. To half its amplitude for the first time. Why the first time? Because of course it's oscillating. It's going to go back many times. We have to be clear about what time we're talking about. So, I can choose either sine or cos, doesn't matter, but I'm moving from equilibrium So I'm going to choose sine because it starts at equilibrium, starts at 0. So I'm going to go x is something sine omega t plus something. Actually, I know I'm starting at equilibrium. I know this is going to be 0. Okay? From equilibrium gives me a sine with alpha being 0. I don't know the amplitude. I have to hope I'm not going to need it. Can I work out what omega is? How do I work out what omega is? You've all done this modelling? I don't mind just leave this by. Somebody? Anybody?
Is it the same way you do it for sine?
Mm-hmm.
2 pi 5?
Uh-huh. Because after this I want to go back to 0 again. So yeah, it's exactly the same. So here, x is a sine 2 pi on 5t. That's my model. I want to work out when it's got to half its amplitude. So this distance is going to be a over 2. 2 pi on 5t. Can we solve that? Yes, we can. A half equals sine of something. Whatever half is sine, what's the angle? Come on, Year 11s, you've just been doing this.
On 6.
Pi on 6. Now, for the first time, right, the first time means I must be in the first quadrant. Because otherwise I'd be over here and I would already have got there the first time here. So I know it's pi on 6 I want. And therefore t is 10 on 6. That's pretty nasty. Did I do that wrong? I did that wrong.
I think so.
What did I do wrong?
Times 5 divided by 2.
Times 5 divided by... divided by 2. So I actually have 5 on 12.
Yep.
Okay. I can stop there then. Yep, 5 on 12 seconds. Oh, that's messy. 5 on 12 seconds. Probably a decimal would be just fine. It's going to be a non-terminating decimal though. It's going to be a recurring one. Okay. Oh, too easy. An object is oscillating, it's hard writing that too, with simple harmonic motion modelled by, they're giving us the model. X equals 3 sine 2 pi t minus pi on 4 meters. And t is in? They're giving me meters, but they haven't actually told me what t represents. But they've assumed it's seconds. Meters. T in seconds. Okay. We have to determine Displacement, velocity, acceleration initially. Determine initial displacement, velocity, acceleration to 2 decimal places.
So if we calculate omega, we can go straight from displacement to acceleration?
Correct.
Alright.
If you can work out what omega is, you can learn all of these things straight away, or you can differentiate. It's up to you. That's right, it can help you if you can read straight away and go, well, I can work out what omega is and therefore. If you want a name for omega, this is the period, so this is the frequency. But it's actually the angular frequency. Because it's got 2 pi in it. It's not just 1/5. It's the angular frequency. In physics, we used to do a whole lot of stuff with angular motion. So you've got displacement, velocity, acceleration. You can do exactly the same things with angle, angular velocity, angular acceleration. There's a whole separate physics, and as long as the angular acceleration is constant, you can apply exactly the same formulas. Omega equals omega naught t plus, etc. You can do all of that stuff that you do with the physics formulas. You can do it with angular momentum and stuff like that, but it's no longer in the syllabus. Okay. Well, displacement is easy when t is 0. Displacement is 3 sine negative pi on 4. Year 11, because you need the practice. Somebody tell me what sine negative pi on 4 is.
Over 2.
1 over 2. Positive or negative?
Isn't it like positive because it's 2 negatives?
Sine of this angle.
Yeah.
Sine is the y coordinate. Is the y coordinate here positive or negative?
Negative.
Negative 3 pi on... No. 1 over 2, wasn't it? Yeah. Why is there a... That's not right. It's 1 over 2. Why did I put a pi in there? If you want me to write it out, one more line for some of you giving me slightly confused looks. 3 times negative 1 on root 2. But the question asks for 2 decimal places. Calculator, please. Where's your calculator, Shannon?
Negative 2.12.
Somebody confirm that, please. See, here's the thing, Shannon. If you don't do it yourself, you come to the exam and there's one more practice you didn't do. And you've just got used to relying on Travis and Eddie and Rain to tell you the answers all the time. Except actually I think it's usually Travis and Eddie. Even Rain gets lazy.
Yeah.
Calculator app, make sure you know how to do it. Do you agree, Shannon? Or April, somebody? Okay, good. Alright, velocity. 3 cos 2 pi t minus pi on 4 times root of the inside 2 pi. I'm doing it from first principles. Well, okay, I'm doing it from calculus rather than just plugging in omega. You should get the same. Did you use omega?
Oh, not for velocity.
Okay, it's root 2 root pi, but yeah, it's pretty disgusting. Velocity is therefore going to be 6 pi cos 2 pi t minus pi on 4 at t equals 0. Velocity is 6 pi cos negative pi on 4. Well, cos pi on 4 and sin pi on 4 are the same. They're both 1 and root 2. But, Claire, is cos of negative pi on 4 positive or negative?
Yeah. Positive.
Positive is correct. Cos is the x coordinate, so it's positive. Or it's crazy. All science teachers are crazy. Okay. That means I've got 6 pi times positive 1 on root 2, which in this case is 6 pi on root 2. Travis and Eddie, if this was an exact answers question, I would probably, an exact external exam, I would probably rationalise both of these.
Yeah.
This is tech active, 2 decimal places, please. Yeah, I don't care about this, but they might. Shannon or April, one of you is going to check this answer.
13.33.
13.33, what did somebody else get?
Same.
Same, okay, excellent. 13.33. Oh, what's my units? It's velocity.
Meters per second.
Meters per second. Don't get confused. It's displaced negative, but its velocity is back towards equilibrium. It can be displaced negative and have its velocity still be going out. But if it's displaced negative, its acceleration is always going to be negative. Sorry, positive, opposite. Its acceleration is always going to be the opposite of displacement, always. Let's check it. Acceleration is derivative of this, negative, oh, that was a funny place to put it, is negative 3, what am I doing, reading this one, not that one, negative 6 pi sine 2 pi t minus pi on 4 times derivative of the inside, which is 2 pi. Which means I've got negative 12 pi squared sine 2 pi t minus pi on 4. And then at t equals 0, keep going and work out the acceleration. Oh, we've done sine negative pi on 4 already. Negative 12 pi times 1/2, which is, oh, it's not negative, 12 pi squared on root 2, or approximately Ronnie got a bit messy.
Yeah, I got the same answer both ways, but 83.75.
Excellent. 83.75 meters per second per second. Oh look, I'm writing my physics per second per seconds. The textbook goes on to talk about springs specifically. That's not in the syllabus. I will mention it. You don't need to know this. For a spring, F is negative kx, and this constant is called the spring constant. That's literally all they do. But they also then determine from that a formula for the period. You do not need to know this formula. Period is 2 pi root m on k. Root square root of the whole lot. Not in the syllabus for this or for physics anymore. Textbook still includes it. It allows you to be able to work out the period if I give you the spring constant in the mass or vice versa. You can ignore those questions. We're not going to ask you that.